Hi class, for this video, I want to talk about the average values of a function. Now, I understand it's very easy for us to calculate the average values of a finally many numbers. So for example, if I want to calculate the average of 20 numbers, I can just add them up and divide by 20, right? But how do we compute let's say if we want to compute temperatures, how do we compute the average temperature during a day if infinitely many temperatures readings are possible? So let me put them together in a graph. So let's say this is temperature and we go 5 Celsius, 10 Celsius, 15 Celsius, and so on. And then we read for 6 hours, 12 hours, 18, 24, okay? But then we take the reading all day long like that, right? Let's just say it's like that. Now, how about I say, okay, I'm gonna guess the average is right here. So let's say that's the average temperature. That's the average. So we can compute the average values of function from A to B, right? Now, if I start dividing the interval, if I start dividing the interval A and B into subinterval, let's say into n intervals and subinterval, and then each length I'm gonna call delta x, so it's b minus a over n. We learned about this, right? So delta x is just b minus a over n. And then we choose points like x1 stars, x2 star, x3 star, and so on. Okay. And then we try to calculate the average. Now, if you calculate it, of course, you're going to get the summation, right? So it's going to be like this. The summation of all of those subinterval f of xi star delta x. Okay. Now, if you take the limit of that, you're going to get the average values function on the interval from A to B, right? So let's say if I want the f function to represent the temperature and n to be 24. So that means I take the reading every hour. Or I can break it and I can say, okay, I'm going to take the reading every minute, or I take the reading every second, and then we average it. And then just like what we did before, we take the average, we take the limit, and we ended up with the integral. So the average values of a function is defined as that. 1 over b minus a. I'm so sorry. This is b minus a. And then we have the interval from a to b f of x dx. So for example, number 1 right there, really easy, right? I give you the function, I give you the interval. So for this problem, to find the average, it's going to be 1 over b minus a. So that's going to be 2 minus negative 1. Integral from 1 to 2. 1 plus x squared dx. Okay, and then from there, we just integrate 1/3. And then what do we have? We have x plus x cubed over 3 going from negative 1 to 2. So it's 1/3. And then you have 2 plus 2 cubed over 3 minus negative 1 plus negative 1 cubed over 3. So in the end, you're going to get 2. Okay, so it's straightforward. nothing special about it. So I'm going to go back to my temperature problems, and sometime, let's say T of T is the temperature at time T. Temperature at time T. Now, we might wonder if there is a specific time when the temperature is the same as the average temperature. So you see right here, it's one right there. Now, if I change the function a little bit, we might get more than one temperature. So that's pretty much indicates the mean values theorem for integral. And that's the mean values theorem for integral. So if f is continuous on AB, then there is a number c such that f of c is going to be the average values of the function. Okay, so it's straightforward. Anyway, let's go to number 2. We want to know, since f of x equals to 1 plus x squared is continuous because it's polynomial, right, on the interval -1, 2. The mean values theorem for integrals say that there is a number c in between -1 and 2, such that the integral from -1 and 2 f of x, which is 1 plus x squared dx, is going to be f of c b minus a. So 2 minus -1. Okay. All right. So we can find c easily. So from example 1 earlier, we know that the average values of function is 2. Okay. So we know that f of c has to be 2. Okay. So we plug it in and we solve for it. So 1 plus c squared has to be 2, and therefore c squared is 1. Therefore, c, you take the square root. Don't forget, when you take the square root, you end up with plus and minus 1, right? Okay, so plus and minus 1 are in the interval, -1 and 2. So it works for the mean values theorem. Okay, so sometime you found two numbers and only one of them is in the interval. You toss out the other one. So we are back to velocity problem. Okay, so let's call S of t is the displacement of the car at t time, or time t. Then by definition, the average velocity would be, so this is the average velocity of the car over the interval. So I have delta S over delta T. So it's going to be S of T2 subtract S of T1 over T2 minus T1. Okay, so straightforward. We know that. All right, now we know the average values of the velocity function is going to be, by definition earlier, we have 1 over t2 minus t1. That's the interval. We go from t1 to t2, and then the function, velocity function, v of t dt. All right, but we know that the velocity function is what? The velocity function is the derivative, right, of the displacement function. So it's going to be s prime of t dt. Okay, we learned that in chapter 2, chapter 3. All right, now from here, by the net change theorem, hopefully you still remember. So I have 1 over t2 minus t1. S t2 minus s of t1, because we integrate of the derivative. So we get back to the function. So if I rewrite, this is exactly like s of t squared. I'm sorry, s of t2 minus s of t1 over t2 minus t1. And there we have it. We have the average velocity.